So here's our lesson on factoring quadratics. You have done this in Algebra 1. I don't know if you reviewed it any in geometry, if you've already taken geometry. So this is just a quick recap, though, of some basic factoring patterns that we need to know. So a few things. First of all, quadratics. We're talking about things that have x squared in them. And then factoring means to basically unmultiply, which you all know is division, but we're talking about it in kind of a different way. So factoring is unmultiplying. So let me remind you, if you had this question here below, so I'm just giving you an example. If you were to, this question is multiplying, so you would distribute this out, and that's going to give you x squared plus 8x minus 3x minus 24, and then we would combine like terms. You're going to end up with x squared plus 5x minus 24. All right, what I want you to make a note of is that this direction is multiplying. But what we're going to work on today is going the other way, and that is called factoring. So for instance, they're going to give me an expression like this at the bottom, and they're going to want me to write it as a multiplication problem. So let's look at how we do that. The first skill that you need to know is how to factor out a GCF. So I would create a few different sections in your notes. This one on factoring out a GCF, as you know, GCF stands for greatest common factor. So you're looking for what is it you can divide into both of these. And the easiest way that I've found to write it in the beginning, if this is not something that you're super comfortable with, is to think about what can I divide both of those things by. And I want to pick the biggest, the greatest thing. So I see I can divide a 4 into 4 and 8. And the first one has an x squared, this is an x, so I can also divide an x. So now I'm actually going to do that. I'm going to do that division. 4 divided by 4 is 1. X squared divided by x is x. And then if I divide this other direction, let me highlight so you see what I'm doing. I'm going to divide this way. Now if I divide this other way, that's going to give me -2. And the x divided by x cancels. And when we do GCF, the biggest thing is we need to bring this GCF out to the front. Because remember, my goal is to write a multiplication problem. So if you were to multiply this back out, 4x times 1x is 4x squared. 4x distributed to the -2 gives me -8x. So I've done this one correctly. The last thing I'll say about GCF, because this is going to come back, is that we need to always, there's a reason this is in red, always factor out GCF first if possible. So sometimes questions are going to be GCF and then something else. So we're going to see that in the next few examples that we do. So trinomials, we call these trinomials because they have 3 terms. So notice that these 2 examples both have 3 terms. I'm going to do 2 examples back to back just so you see the difference. All right, so trinomials, if you've done them on Delta Math before, or when we do them on Delta Math, you'll remember we call this the X game. I need 2 numbers that multiply to something and add to give me something. So my last term right here, that's my multiplier, and my middle term is my add. So I need to come up with 2 numbers that multiply to give me 8 and add to give me 6. If you think about that for a minute, you should come up with 4 and 2. 4 times 2 is 8. 4 plus 2 is 6. And this becomes really easy when we, like these, because when we put them back together, I'm going to split my x squared up to be x times x. And then these 2 numbers that I've chosen, 4 and 2, are simply going to fill in the rest of my factors here. So my answer is going to be x plus 4 times x plus 2. And we can go back and like do that multiplication to prove to ourselves that it works, but I promise you that it will. This is the final answer there. All right, so remember, I said on the last one, the first thing we always need to do is see if there's a GCF. So notice this original example that I just gave you, there's nothing that divides into x squared, a 6x, and an 8. Not into all 3 of them anyway. But if I look at this example on the right side, I notice I can divide all of those by a 2. So my GCF is 2. That's going to leave me with x squared minus 5x plus 6 when I divide. And then remember, my GCF comes down to the front here. And now I've got a trinomial again. So I'm going to set up my x game. I need 2 numbers that multiply to give me 6 and add to give me -5. And you got to be careful with positives and negatives here. I multiply to give me a positive number, which means they either both need to be positive or they both need to be negative. So in this instance, it's -2 and -3. And now this is pretty straightforward. Those are my two numbers, just like in the last one. So I'm going to go ahead and set up my factors like I did the last one. Let me switch my colors. All right, so GCF comes down to the front still, and I'm going to split this part into my two different factors. X squared splits apart to be x and x, and my two numbers are -2 and -3. And that is the final factored version of that trinomial. All right, now sometimes, this is the third trinomial example, it's the last one of the trinomials. Sometimes we kind of get these tricky problems like this one, where the problem here is there's a number in the front, but that number isn't a GCF. Like if I try to divide this by anything, I can't divide 5, 2, and 3 by anything except for 1, which there's no point in doing that because that will just keep it the same thing. So instead of trying to divide a GCF, I do have to deal with this 5. And I'm going to do a method that I call bottoms up. So this 5 is going to multiply out here. And I'm going to do two things to it. I'm going to multiply it, and I'm going to move it. And I'm writing that down, and you should too, because we've got to go back and undo that step here in a minute. I can't just do that because I want to. So if I multiply it and move it, that's going to make my top number -15 now, because I multiplied the 5 by the -3. And my bottom number is -2. All right, you can pause the video for a second to see if you can come up with those two numbers. All right, my two numbers are -5 and +3. And now that I have my two numbers, usually I just go back and write my factors. But don't write this part. I just want to show you what the problem is. If I write my factors right now, x - 5 and x + 3, the problem is that x times x is not going to give me this 5x squared right here. Likewise, -5 times 3 is not going to give me -3. So I've got a few issues going on there. So I can't just write it flat out. So I'm just going to go ahead and keep this written here just so I can cross out for myself that this is not the way to do this question. So what I'm going to have to do is go back to this multiply and move, and I'm going to have to deal with that to fix the issue. So I'm going to set my problem up with the x's in the front, just like I did before. But this time, I originally multiplied by 5. Well, I need to go back and divide by 5. Okay, so this first one, x - 5/5, does divide, and that's going to leave me with x - 1. But the second one, x + 3 divided by 5, that doesn't divide or even simplify. So I took care of the multiplication by dividing. So if you want to make a note to yourself, you have to divide to undo the multiplication. Now I have to fix the moving. And so notice, I like to draw these because it shows that it goes full circle. The 5 moved to the end, right? And now I've got to move it back to in front of the x where it belongs, which means this final factor is going to say 5x + 3. And now if we go to check, x times 5x does give me 5x squared, and -1 times 3 does give me -3. All right, this last one is probably the easiest and also the most important for you to know pretty well. So difference means subtraction. And squares, those are just like those perfect squares numbers that we have done with breaking down square roots, the one we had written on the board. So we're looking for numbers that are perfect squares and they have subtraction between them. So for instance, 9x squared minus 64, these are perfect squares because I can make them 3x times 3x, and 64 can be 8 times 8. All right, the same thing with 16x, that can be 4x times 4x, and 1 is a perfect square, 1 times 1. This last one's got kind of an issue going on, so we'll hold on to it for a minute. So the way that difference of squares works, it creates, I'm going to say opposite, but really they're called conjugate factors. So for instance, I'm going to break the 9x squared up to be 3x times 3x. And this, because this is negative 64, I have to break it up to be plus 8 and minus 8, because the only way to get negative is to have a positive and a negative. And that is all you do for those. I would make a note to yourself that these right here are called conjugate pairs. That word is gonna come back and something that you need to know. So they create conjugate pairs. This next one does break apart because they're perfect. Notice that you've got 4x, 4x, 1, and 1. The problem here is that this is not subtraction. This is addition, which means there's no way for me to create conjugates, positive and negative, because I can't multiply a positive by a negative and get a positive. So that means this right here does not factor. And most of the ones we do will, but this one does not. So that's where we have to leave it. Does not factor. All right. Last one over here. If you remember the very first example I gave you, I told you, you always have to do what first? GCF. So I'm going to divide this and see if there's something that divides into both of those. And I notice a 2 divides into both of them. So if I divide by 2, that's going to leave me with x squared minus 25. GCF comes to the front. And now I have, I'm back to difference of squares. I've got subtraction, that's good. X squared is x times x. 25 is 5 times 5. So when this factors out in the end, my answer should be x plus 5, x minus 5, and my GCF falls down to the front. Please make sure you have all of those examples written down and come ready to work and use them in class tomorrow.